Hi everyone, my name is Rami Munir and I'm excited to be presenting our paper Streamer, Streaming Representation Learning and Event Segmentation in a Hierarchical Manner. This work is a collaboration between myself, Sujal Vijayaraghavan, and my advisor Sudeep Sarkar at the University of South Florida. The goal of this work is to process untrimmed streaming videos of possibly infinite duration and output a hierarchical structure of segmented events. The output event representation should be robust enough and semantically rich to be used for event retrieval across videos. As can be seen in this example, Streamer temporally segments the events of a novel streaming video in a hierarchical manner. As we go higher in the hierarchy, some events that were previously separated at low levels can now be grouped together at higher levels and are given different representations. More examples are available on our project page. We achieve this using a predictive learning approach that is inspired by cognitive psychology theories, such as event segmentation theory and biologically plausible architectures. First, we consider a simple predictive model that receives input x at t and attempts to predict future input x at t plus 1. The difference between the prediction and the actual input formulates an objective function that trains the predictor. In cases where the input consists of a sequence of multiple inputs, a temporal encoder such as a transformer or recurrent network is needed to summarize the sequence into a single representation. In our case, we use a transformer encoder architecture with learnable positional embeddings. This gives us a representation Z of this set of inputs X. Now consider this temporal encoding process occurring at all levels of the hierarchy, giving us multi-level representations. We use this multi-level representation as input to the predictor, such that the predictor function at each level can access higher level and lower level contextual information during prediction. Now the last piece of the puzzle is a loss function that minimizes the prediction error by training the predictor and the temporal encoding of all levels. The loss value is also used to decide if the next input belongs to the current event or if it belongs to a new event, a process we call event demarcation. The whole model is trained through this single predictive objective function repeated at all levels of the hierarchy. We simplify the diagram by using a green arrow for same event decision and a red arrow for new event decision. Although each level performs the same operations of encoding and prediction, it is important to note that the levels operate at their own subjective timescale because higher levels receive sparser inputs. This animation of information flow shows our algorithm operating in real time. The cyan circles are inputs, and the gray boxes show the start and the end of an event. These events can be extended if the prediction matches the actual input. Otherwise, the representation is propagated upward to be used as input for a higher level. Higher levels perform higher order predictions on the representations that they receive from lower levels. We show that Streamer outperforms state-of-the-art models on the Epic Kitchens dataset using a simple 4-layer CNN as backbone that is trained from scratch. This is compared to more sophisticated backbone architectures that use features supervised on Epic Kitchens or ImageNet. Qualitatively, Streamer boundaries match with the ground truth better than other methods. We also show that our pre-trained features of a 4-layer CNN backbone enhance the performance of clustering-based state-of-the-art approaches significantly. We also design an event retrieval task where a model is required to rank 10 events based on their similarity to random query events. The dataset is constructed by prompting the large language model, GPT 3.5, to rank events based on their Epic Kitchens labels. Results show that the event representation of our self-supervised model align better with the ranking of the LLM than supervised representations of state-of-the-art approaches. We also show qualitative retrieval results across different videos for Streamer and other methods. Streamer retrieves more semantically similar results across different videos. When we query random events, we can retrieve visually different yet semantically similar events from other videos. Please visit our project page for more results.